Hello students. In the last video we had discussed about the properties of acids and bases. There we had seen that all the acids, whenever they react with the metals, they are releasing hydrogen gas. That means the acids, they are having the hydrogen atoms. So does it mean that every substance which is having hydrogen, it can be called as acid? So let's find out, like ethyl alcohol. The formula of ethyl alcohol is C2H5OH. Glucose, its formula is C6H12O6. So all these substances which are also containing hydrogen, can they be called as acids? So we will find out with the help of an activity. What do all acids and bases have in common? Let's find out. Here first I would like to discuss this experimental setup with you. In this experiment we had fixed two iron nails on rubber cork. A rubber cork has been taken and two iron nails are fixed on this rubber cork. Okay. Place it in the beaker and this rubber cork, now it is placed in this beaker. Connect the iron nails with battery, bulb and a switch. We had connected this iron nail with the battery. These are the two terminals of the battery. Then it is connected with the bulb and then through a switch it is connected to the another nail. Okay. Now fill different solutions one by one. We are going to fill in this beaker different solutions like dilute hydrochloric acid, dilute sulfuric acid, sodium hydroxide solution, calcium hydroxide solution, ethyl alcohol solution and then glucose solution. So we are going to fill 6 solutions one by one. Then check when does bulb glows. Every time we have to find out when this bulb glows. Okay, so this is our experimental setup. This is the diagram. I had done the labeling over here. You can see battery, bulb, switch it is, beaker, solution. I had not written any particular solution. One by one we are going to fill the different solution. Then these are two iron nails and this is the rubber cork. Fine. Let's start with the observation part. First, when we fill dilute hydrochloric acid, the bulb glows. Okay. When we fill dilute sulfuric acid, then also the bulb glows. When you fill sodium hydroxide solution, then also the bulb glows. Okay. Calcium hydroxide solution, again the bulb glows. When you fill ethyl alcohol solution, the bulb does not glows. And when you fill glucose solution, it again does not glows. So first thing, it is clear that it is not necessary that if they are having hydrogen atom, that means they are conducting, they are passing the electricity. We cannot say that presence of merely the presence of hydrogen atom cannot be considered as a property to be called as acid. Okay. So with this, what we had concluded, conclusion, acids and bases on dissociation in water produces ions. Okay. Now let's consider this activity. If this bulb has to be glow, what should be there? This solution which is filled in this beaker, it should be conducting. Okay, it should be conducting, then only the circuit will be complete and the bulb will glow. Okay, now when this solution will be conducting? When it is producing ions. Okay, because the ions are going to conduct the electricity, and in the Arrhenius concept we had seen that for an acid to be called as acid, it should dissociate to form H plus ion and a corresponding anion. For a base to be called as base, it is going to dissociate into hydroxide ions and a corresponding cation. That means acids and bases, they dissociate in water into ions. For dilute HCl, we can write it dissociates to form H plus ions and Cl minus ions. That means it is giving ions. When ions are present, the solution becomes conducting because the ions conduct the electricity and the circuit gets completed and the bulb glows. Similarly, for all these, H2SO4, it's going to form H plus ions, 2H plus ions, and along with that, sulfate ions. NaOH solution, a base, it is also going to dissociate to form Na plus and OH minus, sodium ions and hydroxide ions. Calcium hydroxide, this solution is also going to dissociate in presence of water. It will form Ca plus 2 ions along with hydroxide ions. But these two compounds, ethyl alcohol and glucose solution, they both are covalent compounds. About covalent compounds, we are going to study in detail in the 4th chapter, students. Here I would like to tell you this thing only, that covalent compounds do not form the ions. So here in all the 4 cases they are producing ions, but here in this 2, ethyl alcohol and glucose, though they are having hydrogen, but they do not ionize to form ions because they are covalent compounds. So the conclusion is that acids and bases on dissociation in water produces ions, as we had seen, which conducts the electricity. Okay, now there are two terms, electrolytes and non-electrolytes. So electrolytes are the solutions which conducts electricity. So we can say these 4 are the solutions, they are called as electrolytes, and non-electrolytes which do not conduct electricity. What happens to acid or base in a solution? This is our next topic. Let's see what happens when they are dissolved in water. As students, we had already seen and we had already discussed also, but here by means of an activity we will prove it. What happens when acid is dissolved in water? You already know, we had already discussed that according to the Arrhenius concept, acid dissolves in water to produce hydrogen ions and the corresponding anion, and similarly bases, they also produces the ions. So here I have written a sentence, acids and bases shows their nature in presence of water only. Without water, they cannot be called as acid or base because their separation into hydrogen ion and the anion will take place only and only in the presence of water. The water has a specific role to play. This water, it is playing a specific role. It separates hydrogen ions and anions in acid. As we had seen, HCl was giving H plus ion and the chloride ions. Similarly, it separates hydroxide ions and cations in base. That means NaOH, it was getting separated into Na plus and OH minus. And this process, it is called as dissociation. Or you can write it as ionization. Okay, now let's see the activity. Here in a test tube, we had taken NaCl and concentrated H2SO4, and this has been one cork has been placed on this test tube. So whatever the gas is formed, it should not escape out, and in this one delivery tube has been placed. It is fitted over there, and in this delivery tube, students, you can find out this anhydrous calcium chloride has been plugged. And what is the nature of anhydrous calcium chloride? That it absorbs the moisture. Okay, now this is our setup. When the two reacts, NaCl and H2SO4 reacts, what happens? Let's write the reaction, NaCl plus H2SO4. When the two react, it forms NaHSO4 plus 1H combines with this Cl. Okay, now we are getting HCl gas. So here, after the reaction, one gas is formed and it rises up through this delivery tube where it is taken out here, and we are bringing this. As you can see over here, this is the blue litmus paper. Okay, now blue litmus paper. Students, in the beginning, we are bringing the dry. I am just writing, we are bringing a dry blue litmus paper. So, when we bring this dry blue litmus paper in contact with this HCl, it does not turn to red. So, I will write down the observation, does not turn red. Now the question comes to our mind कि when it is in HCl, we had already seen that HCl dissociates to form H plus and Cl minus. So why it is not converting the color from blue to red? Why? What is the reason? So I guess you can give me the answer. Here this HCl, hydrogen chloride, is a gas and it is a covalent compound. Okay, so it is not called as acid. For HCl to be called as an acid, it requires water. Okay, so here instead of dry blue litmus paper, if you will bring moist blue litmus paper, it converts to red, changes to red. So now here it is showing its acidic nature. This HCl, it dissociates to form H plus and Cl minus, and because of the presence of H plus ions, the color of this moist blue litmus paper converts to red. So we can conclude that for an acid to be called as an acid, it requires water. Okay, without water or in the absence of water, it cannot show its acidic nature. This H plus ions cannot exist as it is, so it combines, H plus combines with water molecule and they form hydronium ion. This is H3O plus and the name it is hydronium ion. Okay, so here we can say that for an acid to be called as an acid, it requires water. Similarly, for a base to be called as water, for a base to be called as base, it requires the water. Similarly, for example, if NaOH is there, if it has to be called as base, it requires the water. Only in the presence of water, it will dissociate to form OH minus and Na plus. So here OH minus ions will be given only and only in the presence of water. So in this activity we had concluded the importance of this water. Now one more thing students over here, what happens, one more topic I would like to discuss here only, it's a small topic, let's see it over here only. If you are having two test tubes, okay, one is having water, okay, one is having acid. Now to this water I am adding acid, and to this acid I am adding water. Okay, what is our purpose? Dilution. Dilution of acid. Dilution of acid, that means acid plus water. Simple, acid plus water. If you will add water to the acid or acid to the water, the dilution will take place. So here the two methods are there. Either you add acid to the water, or in the second case water to the acid. Okay, so what is the difference between the two? First thing I would like to tell you about this reaction, it is highly exothermic. Highly exothermic means during the reaction a large amount of heat is generated. Okay, so when you are adding water to the acid, this is a wrong process. When you have to the dilution, acid should be added to the water with constant stirring and slowly. So the first way to dilute an acid is correct. First you will take water in a beaker and then you will add acid slowly, and that too with constant stirring. Okay, and if you will do this one, what can happen? If you will add water to the acid, suddenly a large amount of heat will be generated, and because of that the solution will splash out. Because of that it can cause burns also. This test tube can break. So we can say if we have to dilute an acid, the acid should be added to water. There are questions in the NCERT where they had asked how to do the dilution of an acid and why. Okay, now second thing, when this dilution of an acid is done, what is happening actually inside? The H ions or OH ions, if you are taking the base, H ions per unit volume decreases. So what we are saying, with the dilution, the number of hydrogen ions per unit volume are decreasing. If you have to decrease the concentration of an acid, you will add water, because the number of H ions per unit volume are getting decreased. If you have to increase the strength of an acid, you will add some more acid to it, so that the hydrogen ions per unit volume will increase. Students, the questions are given in the book. I'll take one question so that you can be comfortable with us. Okay. How is the concentration of hydronium ions affected when a solution of an acid is diluted? So you will write down the number of hydrogen ions per unit volume decreases. How is the concentration of hydroxide ion affected when excess of base is dissolved in a solution of sodium hydroxide? So in NaOH you are adding excess of base, that means you are adding OH minus ions. So what you will say, concentration of OH ions will increase per unit volume. Okay, so in this way students you can do the questions. In the next video we will discuss the pH. What is the meaning of pH and what is the importance of the pH in our daily life. Thank you.